Welcome back to the powerhouse with your mathematical meathead himself, this guy. All right, folks, let's talk about volume. Volume of 3D shapes. Now we're getting into some interesting stuff here. Interesting stuff. We've talked area, we've talked surface area. Volume is a natural evolution of our introductory geometry. So, I guess the best way of describing, well, what volume really is um, the amount of stuff that can fit inside some dimensions, if that makes sense. The amount of stuff inside some other object. So, for example, think of think of a cereal. This one here actually kind of looks like a cereal box. Maybe, sorta, right? But you can imagine that if we're talking volume, we're talking how much cereal can we fit into this box that I've got right here. Okay, this box here. Or, hold on, that's for later. Okay, so yeah, cereal box, cereal, all over the place here. There we go. Cereal box. How much cereal can fit in here? Or if maybe a moving box, how much um, toys or whatever you can fit in your moving box. So the nice thing about volume is, in some ways, it's not as complicated as surface area. You don't necessarily have to break down things into their component shapes. The idea with uh, volume for prisms is identify the face. Identify the face. So in other words, identify the shape that has there's two of, for example. In this case, you can use, there's a couple different faces you can look at, but generally the way I like to identify a face versus the other object it's surrounded by is for example, there appears to be more of these long, skinny pieces, right? Long, skinny pieces, then there appears to be big, huge square faces. So for me, I'm saying my face are these squares, and I've got these long, skinny pieces. Now, how do you solve volume uh, volume problems as they relate to prisms? In this case, a square prism. Well, let me go ahead and write down my dimensions here of my face. Faces are the same, by the way. Just a reminder, one face is the same exact dimensions as another face. So this drawing here tells me that this side is 10, as well as this height here is 10, right? It's a square, it's 10 by 10. So I can write it generally to say that to calculate volume, you want to take the area of 2D, the 2D face, and then you want to multiply it by, I'll call it the depth, or um, I'll call it depth times depth, right? It's just the thing about, volume applies to 3D objects, by the way. And the thing about 3D is that it is the depth factor that makes things in the world 3D. Um, so according to our drawing here, the depth is whatever. I'll use a different color here so it's very clear. The depth, right, this goes back into if you can imagine, it goes further back by this purple amount. This purple amount. Okay, and so this purple amount here, which the diagram is saying it's 4. Um, so area of 2D face, well, we know it's a square. So square, oh, okay, hold on. Square equals length times width equals, uh, well, 10 times 10. And that equals 100. So I'll just plug in 100 right here, multiplied by, well, the diagram's telling us the depth, 4. Multiply these together, 4 times 100, get 400. Easy, easy guys, very easy. Much easier than surface area. And if you want to be particularly correct, units, right? Again, I won't ding you for missing units. I just want to know that, one, you can come up with this formula, plug the right numbers in, come up with a result. That's all I care about. So, easy enough, right? That was kind of fun. Let's move on to the next one. Oh, okay, all right. Now we got a different, yeah, we got a different type of prism here, a different type of prism. Again, we know it's a prism because there are lots of little box-like objects floating around. There's more box-like objects than there are faces. So there's one, there's two, and then if you look, again, it's kind of a trick of the eyeballs here, but um, you can also imagine this as being that, another box-like, right? So there's only two faces. The two shapes that I see that stand out are, I'll write here first before I even do that. I'll write what this is: triangular prism. And the two face-like objects that stand out to me are these little right triangles here. And there's two of them. All right, and then I got some what looks to be squares or rectangles, which I'll deal with that in a second. But you can tell from the diagram here, this side of the triangle is 4, this side is 3. So 3, 4, 3, 4. This is the base. This is the height. Same thing. Height equals 4, base equals 3. The reason that's important is because we know, right, what we just talked about with the square prism was that we want to create a volume formula such that we have the area of our 2D face, just the normal area, times our depth. Right, so, and we know that triangle areas, oh, wow, hold on. We know that the area, the standard 2D face area of a triangle is 1/2 times base times height. You got to commit this one to memory, guys. Some things in math you just have to know. This is one such thing, right? 1/2 base times height. More than likely, I'll give it to you I'll explicitly write it out for you on a homework or a quiz, right? But in order to get points, I want to see that, one, you recognize and basically repeat writing the formula, and then plug the numbers in as appropriate, etc., etc. But anyways, and wait, let's talk about depth real quick. That's the last piece we need before we can calculate this thing. So here again, here's my triangle, and it just goes back, back, back. This amount of length, this amount of depth, which these are the same here, and it's saying that it's 7. So depth is 7. Okay, now we got all the pieces, guys. We have all the pieces. So let's start putting things where they belong. See our area of a triangle, base times height. So I'll say 3 times 4 times, we said the depth was 7. Nice. So working out a little bit more, we know our 3 times our 4, that gives us 12. We still have our 1/2 out here. We didn't do nothing with it, so we can't forget about it. We still have this 7 out here. Don't forget about it. Okay, that's what your next line should look like. 12 times 1/2, or in other words, the way to look at that is 12 divided by 2, which is 6. Again, bring the 7 down. Now it's looking pretty good, guys. 6 times 7. Drum roll. Final answer is 42. 42. And, of course, units. And, actually, with volume, they're cubed. I think I may have written squared earlier. Yeah, I did. It's cubed. Volume is cubed. Again, units are not something I'm going to harp on too much, but I want it to be correct there. You'll learn a little bit more about it next year, units and why things are squared versus cubed. Again, I just want you to know the formula, how to plug stuff in and get a number. Boom, that's the answer, 42. Okay, all right. Boom, now we got pyramid volumes. These can be a little challenging, I gotta say. Well, not challenging, but intimidating when you see the formula, right? Each volume, each shape has its own formula. This one here, it wasn't too bad. Area of 2D face times depth. But when you see this one, guys, wow, you're gonna be like, oh wow, okay, I'm scared now. But don't be. All right, anyways, so square pyramid. Square because the base is 4 by 4. Even though it looks sort of rectangular, it says 4 by 4. So that's why we say square. Anyways, though. So well, let's write out the square first, because we know we're going to have to find the area of our 2D face, or in this case, base. So we know that, or if you didn't, I'm telling you, that's one of the components here. So I'll go ahead and write this out early. Anyways, there's 4 by 4 square, multiply together. We know our square is going to be 16 inches squared. Square because, again, area of the 2D, right? Maybe I won't even do units, just not to confuse people. There you go. All right, now, so that's kind of out of the way. We'll keep that on the back burner for later. Now, what you want to do is, let me just write out the formula here real quick. Volume of a pyramid is, and I'll explain here in a second, right? 1/3 times the area of the 2D base times the height of the pyramid itself. The pyramid itself, which is basically saying from the tip, right here, the tip, straight up, the tip, and then straight down, right to the middle of the base. That is the height of the pyramid. Sometimes you'll see a height that looks like this, that goes along this triangle here. It's actually called a slant height. That's not the right height. Don't get tricked by that if you see it in a problem. Okay. Height of pyramid refers to from the tip down to the base, straight down. Now, where's this 1/3 come from? You know, wow, whoa, hold on. Where does this 1/3 come from? Well, I explained in a previous video that volume of a pyramid. Actually take a 4 by 4 by 4 cube and this 4 by 4 pyramid, right? The idea is that you can fit, or like if you did the volume of a 4 by 4 by 4 cube, I'll try to draw one out here. So I got 4, 4, and 4. Right, 4 times 4, 16, times another 4. That is 64, right? Yeah, 64. That equals 64. Well, people have done experiments, and they've come to the realization that if you fit the same exact base dimensions of a pyramid, so I apologize for the drawing here. I'm not the best artist in the world, right? But imagine a pyramid. I put a pyramid inside of this cube. Well, through experiments, people have determined that the amount of stuff you can fit in a cube is 3 times the amount of stuff you can fit inside the pyramid. Or in other words, if you just want to know the pyramid amount of stuff that you can put in a pyramid or volume, for example, it's 1/3 that of a cube. So that's where this 1/3 comes from. You don't necessarily need to know why. For this class, you may prove it one day in a higher level math class, but commit this to memory. Commit this to memory. Know that there's going to be a 1/3 out there. You know, you'll see on the homeworks an answer choice that looks fairly correct with the, if you multiply this and you multiply this, and it'll come out to some number, and you'll think, oh yeah, that's right. But it's kind of a trick there, guys, because they put that there with the idea that, oh, they forgot to do the 1/3, so let's trip them up a bit, right? So whatever this is, whatever number that is, you gotta multiply it by 1/3, right? Anyways, let's work this one here, and you'll see. Well, I love switching up the colors, so let's do so. Okay, volume. Well, let's see, area of my 2D base. Well, I said it already earlier, 16. So, whoa, oh wow, that's sloppy, right? Okay, great. And that's supposed to be equals. There you go, 16. Not too bad there. And now from the diagram, I can see that my height of my pyramid, again, tip down straight to the base, 90-degree angle, right in the middle there, 3 inches. 3. Not really too bad, just a little intimidating because that 1/3. So 16 times 3 is, let's see, 48. 48. So these two multiplied together is 48. Still have my 1/3, guys. Don't forget it. The answer will say 48. One of them on a multiple choice. Nope, that's not right. Okay, now, again, you can think of this as being divided by, right? So 48 divided by 3, or multiply by 1/3, right? So really, when you see that, get comfortable with the idea. When you see this, get comfortable with the idea that it's really meaning this. I don't want really you to do this. I don't want you to do this on your paper. I want to see it written out just like this. But if you have to, off on the side, like I do sometimes with the scratch pad math, then by all means, right? But when you perform that specific calculation, 48 divided by 3 comes out to be 16. 16. Boom. So we'll see on the homework, on the quiz, 16 as the answer choice. That is correct. That is correct. Inches cubed, if you want to be accurate. Again, not too bad, not too bad. You just have to understand. That the 1/3 is the big twist here. Anyways, got one more type of volume problem to look at, right? Our old friend the cylinder. Our old friend the cylinder. Again, cylinder. or very much like a prism or a circular prism in any way, right? My 2D face, this nice big huge circle here. I got two faces here. Then I got all along the side, right, this big square-like thing running across the side, all around, right? Here, 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 right? Colored in. That's getting a little messy, but you get the idea, right? Messy. Okay. Well, just like with prisms, guys, just like with prisms. So, my circle, let's see, 5. So if I do area of circle, which I already know to be pi r squared, which we talked about before in the last video, right? Plug everything in. Pi is a number. Plug the radius in. 5 squared. So area of my 2D base, or my or face, my 2D face, or my circle is in fact 25 pi. I'm going to allow you to leave it as pi, so you don't have to multiply 25 times 3.14, get 78. Nope, just leave it as 25 pi. That's what you'll do in higher level math. So anyways, let's build out our high level equation here. We got area of 2D face times depth. Oh, hold on. Too far, too far, too far. Okay, nice. Now maybe just a little. There we go. Our depth is the only thing we don't know. We just figured this out. This whole thing, right, we just figured out is that. So our depth is the only thing we're really missing at this point. Diagram tells us, though, is this, and it's saying it's 4. So now I got all the pieces. We got all the pieces, guys. 25 pi times 4. Multiply together. Volume equals 100. 25 times 4. Just worry about the numbers. Don't even worry about the pi. The pi just comes along for the ride. Just a passenger in the vehicle. Anyways. Right, yards cubed if you want to be correct about units. But that's it, guys, really, for volume, as far as what we will be doing for homeworks and quizzes and so forth. So I hope this has been informative. I hope you got a good pump on. I hope you got the those mental muscles burning right now, guys, because it's a lot. It's a lot, but you guys are doing great so far. So keep it up. Keep on plugging along, and you will do wonderfully on the homework assignments and quiz. All right. See you next time. Bye.